Hello everybody, this is Davide Falessi, the multimedia editor of Valuable Software, and today I have the pleasure to introduce the November-December IEEE Software special issue, which is on refactoring. And I will introduce the special issue by interviewing three guest editors, Emerson Murphy-Hill, Don Roberts, and Peter Summerland. Emerson Murphy-Hill is an associate professor in North Carolina State University at the Department of Computer Science. Hi, Emerson. How are you?
Good. Thanks very much.
Don Roberts is an associate professor in the University of Evansville in Indiana at the Department of Electrical Engineering and Computer Science. And he is also an independent consultant. Hi, Don. How are you?
Doing well. Thank you.
Last but not least, Peter Summerland is the director of the Institute for Software and a professor of software engineering at the HSR Rapperswil. Hi, Peter. How are you?
I'm fine. Thank you.
Great. So let's start with the first question. What is refactoring and how would you define it? Emerson, can you provide an answer to this?
Sure. So simply put, refactoring is a type of software change, and specifically it's the type of software change where the structure of code is changed, but the behavior is left preserved, and typically behavior from the perspective of the user.
Okay. Emerson, why do you think refactoring is an interesting topic?
I think it's a powerful idea that allows us to talk about the types of changes we're making and the types of changes that we want to make. So I think it's good as a communication mechanism. So not only do we have the word refactoring, but we also have a variety of different types of refactorings to talk about. Things like renaming, which is a very common type of refactoring where people change the names of entities in their programs, but also things like extracting methods, extracting classes, moving things around. So the communication is a big part of it. When I say extract method, other developers who know about refactoring will know exactly what I mean. But it's also important in the sense that it helps us maintain large software systems. Ever since code has been structured, it's needed to be restructured because nobody gets design right the first time. So powerful it's powerful and it's interesting in the sense that it helps us recover from mistakes we've made in the past.
Okay. So why do readers need to be aware of what's going on regarding this topic? Don, can you provide an answer to this?
Well, in the past several years, refactoring has started to be built into all of the major tool chains, and the technology really is getting pretty mature. And so even despite that, we see relatively low rates of adoption of refactoring. A lot of people will tend to do these operations manually rather than relying on the tools. And so we really need to make developers aware of what's available and the effort that's gone into making these tools useful and reliable.
It's also a matter of education. So what we do with our students, we teach refactoring from the first lesson on. So we tell them that they have to make their code simpler to actually make it more manageable in the future when they write larger systems.
Okay. So the next question is for Emerson, and it is, why is IEEE software covering refactoring now? I mean, what makes it especially timely?
So I think one reason is because we're kind of being deluged and overwhelmed by large software systems that are out there. Even newer software systems that have been developed in the last few years are getting really big and really unwieldy. So the amount of duplication in these systems, the amount of bit rot, technical debt tends to grow and grow and grow as these systems are getting really big, and we need some way to deal with them. And there's a few different techniques, but refactoring is a technique that's been shown in practice and is shown in the literature as a good way to deal with these types of challenges. So as we move into the future, we need some way to deal with these problems, and refactoring is a good thing to do. And at the same time, as Don mentioned, there are lots of good tools out there for doing refactoring now in Eclipse and Visual Studio and IntelliJ. Most environments that are worth their salt have good refactoring tools built in. They're not perfect, but they're better than doing it manually. So there's not these days. There's not much of an excuse for not using the tools. So it's a great development.
Okay. Don, do you want to add anything on top of it?
No, I think we in the previous question, this question, we've answered that. So.
Okay. The next question is still for Emerson, and is how do we integrate refactoring more naturally into software development process?
So I think that a lot of the software developers that I see doing their work are already integrating refactoring into their work. They may not think of it necessarily of refactoring, it's just sort of part of what they do, but making changes that don't change behavior helps us make other types of changes like fixing bugs or like adding features. So it's really quite a natural thing to do. There is a choice that developers always have to make about, are they going to refactor now, or are they going to put it? Are they going to wait until later to do refactoring? And in terms of making it more natural, making it a little bit more efficient, I think now is always a better time than later. Of course, it can be overdone. You can sort of prematurely optimize when you don't need it. But I would encourage developers to refactor whenever they're making a change and the current design of their software is impeding that change. Do the refactoring to make the type of change you want to do easier to make. And like I said, there are good tools out there for doing it. The tools aren't perfect, but they're pretty easy to use. And people and toolsmiths are coming up with new designs for tools that are making them even easier.
Okay.
If I might add to that, it's not only the tools and the use of the tools, is also the goal where you want to go to. So refactoring without a goal of better design is not what you should do. But so we need also to teach what is good design, and simplicity is a good indicator. If you can make your code simpler, then that's the way you should go. Otherwise, we cannot cope with the complexity that is just lurking around the corner. And I think the term technical debt that we already used in this session is something that clearly describes not only to technical people but also to managers that there are issues with creating a solution. It will not be perfect, and to sustain the solution for a longer time, to expand it, evolve it, you actually have to pay off the technical debt. Otherwise, the interest rate is just too high, getting you into bankruptcy.
Mm-hmm. So the other question is a little bit different from the others, and it's about programming language. So the question is one programming language more easy to refactor than others? Don, can you answer?
Yeah, I'll answer that one. There's been this meme going around, or for several years actually, that we can refactor statically typed languages like Java because there's the type information there to aid the refactoring process. But dynamic languages like Python or Ruby and so forth, we just couldn't do those. And that's just not true. In fact, the first commercial refactoring tool was done in Smalltalk, which is dynamically typed like these other languages, and was quite successful and quite reliable. And so whether one language is easy or not often just depends on how good the tools are to support parsing and analyzing the language. And so, again, another thing, and I know Peter will speak to this, for a long time it was thought, you just can't refactor C++. It's just too complicated. But there's been a lot of work in recent years with Peter and his group and with the LLVM group in analyzing and parsing and manipulating C++ code. So that's kind of the opposite spectrum. You've got a language that's so complicated, but even there are very good tools now for refactoring. So that that argument just doesn't have much weight anymore.
Okay, very good. And the last question is for Peter, and it is, can you talk about language modernization and how this relates to software refactoring?
Yeah, I'm currently attending a C++ conference where the inventor of C++, Bjarne Strostrup, actually showed us a project trying to give people advice on how modern and good C++ should look like. And actually, the new C++ standards starting from 2011 one actually make C++ a different language. So what is considered good C++ today is no longer what was considered good C++, let's say 10, 15, or even 20 years ago. And we have a lot of code that is still written in the style of the 1990s. And today, actually, good C++ is different. So we need to change that, adapt that. And it's not only changing an API that is, let's say, modernized. That's what Google is working on very heavily, on modernization, refactorings for APIs. But it's also the whole program structures that need to change to make things more elegant, more easier to read, or more efficient by exploring new language features. And I think there's a whole bunch of things going on. We've seen similar issues with different versions of Java and refactorings, trying to modernize things. And we will continue to have to work on that for C++ and other languages. It's not only language modernization, it's also API modernization. And one of the biggest problems I'm seeing today is a lot of code is today written in JavaScript, but it's a simple language, but the environments are so hugely different that actually changing JavaScript from one framework to another is a complete rewrite. And I'm staying tuned to what will happen in the next years with the many JavaScript libraries around or frameworks around, and the code written from one that might go extinct, and how is it ported to another one. And that's also something interesting besides my overall project addressing C++.
Okay, thank you very much. So I thank you, the listeners, for listening us, and I thank you, Emerson Marfield, Don Roberts, and Peter Summerland for providing this great introduction to the November-December iDeploy Software special issue of Software Refactoring. Thank you. Thank you very much.
Thank you.
Thank you.
Thanks.